All right, let's go ahead and get started with today's lesson, implicit differentiation. All right, as you all know, I'm not here today, and the person in my place is in the back or in the front, wherever he or she might be, and go and watch things for me, watch you guys for me. So this is something new, implicit differentiation. So let's go ahead and get started. First of all, I guess you got to know what the word implicit means. Differentiation obviously means take the derivative, but differentiation means to take the derivative. Implicit means the opposite of what explicit does. Explicit functions are defined as y equals or f of x equals. Notice we're talking about functions in this case. So in that regard, that's what an explicit function is. Explicit means expressly defined for y. You know exactly what y equals. No more than one y in the problem. Okay? And most of algebra is what the y equals. So, an example of this is y equals 2x squared minus 3x plus 2. That is an explicit function. So if I were to use explicit differentiation, if I want to do explicit, oh yeah, that looks pretty good. Explicit differentiation. I'm not sure how well you can see that, but it looks pretty cool from where I'm sitting. Explicit differentiation means you take the derivative of an equation that says y equals. So that's not too difficult. This one says, so y prime equals 4x minus 3. That's kind of a big deal. The derivative of y prime is, or the derivative of y is y prime. Okay? And then you have 4x minus 3. So that's explicit differentiation. And notice the derivative of y is y prime. Use the power rule right here, dropped it down and multiplied, subtracted 1. Dropped it down, multiplied, subtracted 1. Dropped it down, didn't have to subtract 1 because the whole term went to 0. All right? So that's using the power rule. Pretty easy. So, and we said as an example of explicit differentiation. Big, long, fancy word just means I took the derivative of something defined for y equals. Moving along. Implicit are functions or equations. Could be functions or equations. They don't have to be functions or equations that don't say y equals on them. So, one of those could be x squared plus y squared equals 1. That is obviously an equation of a circle centered at the origin with a radius of 1. That's not a very good circle. But that's a circle centered at the origin radius of 1. Whenever you have an implicit function, anytime you have a y, you have to think of it as using the chain rule. Automatically, in your notes, automatically in the problem, if you don't have y by itself, in other words, an isolated y, you automatically put parentheses around it, and you invoke the chain rule. And that should be pretty easy to remember. So, to find the derivative of this, well, first of all, we're going to see how many explicit functions can you define. I always think of this as how many y equals equations can you write. And obviously, you can write y equals plus or minus the square root of 1 minus x squared. So I'd put down 2. Some people will put down more than 1 or more than 2, but I just go with 2 equations. That's fine. I'm not going to actually do this on a test. The explicit, I always think of as y equals. You can think of it as x equals also. And I give you another 2 equations, but I just go y equals. All right? So that's the answer of 2. So back to taking the derivative. If I was going to take the derivative of this, the only difference is to apply the chain rule I've already talked about to y for implicit functions. Okay? So the only difference in this type of differentiation is you're going to apply the chain rule, which I said. So if you have y, say you had like x plus the sine of y equals 1. I'm going to ad lib this. The first thing you would do is you would put your parentheses around the y. Now if I want to take the derivative, well, what's the derivative of x? Well, the derivative of x is going to be 1. The derivative of sine of y would be cosine of y. And then the derivative of the inside is y prime. And the derivative of 1 is going to be 0. So you have y prime times the cosine of y equals negative 1. Y prime equals negative 1 over cosine of y. So y prime equals the secant of y. Okay? That's how you do the chain rule for implicit functions. And you always put a parenthesis there, and then you go after it that way. I'm going to erase this one. There's more examples, but I want to get that in before it got too far away. Okay? There'll be more examples, but I want to show you how that works with the problem, because obviously I'm a little rusty at using this lesson. So the derivative of y, we already said, is y prime. So we're in good shape. Here we go. X squared plus y squared equals 1. First thing to think of, this is your thought, is that parenthesis around the y squared. The next thing to do is to take the derivative. And the derivative of x squared is obviously going to be 2x. You drop the 2, subtract the 1, that's fine. You drop the 2 in front of the y, subtract the 1, then multiply by the derivative of the inside. Remember, the chain rule is always about the derivative of the inside. So that's where that comes from. Du dx, so to speak. Okay? Du dy, so to speak. Now, one other thing. First thing is you put your parentheses around the y. The second thing is use a chain rule for y, and you also do it for x if you have to. The third thing is to answer the question. You have to get y prime by itself equaling something. And in your answer, you can have x's and y's in your answer. Why can you have x's and y's? Well, because the problem isn't explicitly defined. So you can implicitly define the derivative. That's what you're doing. You're explaining what the derivative is using an implicit definition, not explicit. Okay? Explicitly would be only in form of x's. So you got x's and y's. All right? Sounds good. So, with that said, you finish this problem off. You subtract the 2x to the other side and divide, and that is your derivative for x squared plus y squared equals 1. If you're going to find the slope anywhere on this circle, that's tangent. You have to use both x and y to find the slope of the tangent line. Even though it's not a function, a graph can still have slope at a point. Notice, if I'm at the point 0, 1, I put 0, 1 into my derivative, y prime, 0 over 1, I end up with 0. That is the slope of the tangent line. There you go. Okay, it should be tangent. I'll just make it a big point. Now, if I want to check the slope of the tangent line at 1, 0, y prime equals negative 1 over 0, well, then that tells you that that's a vertical tangent line. Okay? It has no slope. So you can see that you're going to have to use both x and y to find the slope of the tangent line when you're doing implicit differentiation. So, a lot of things to do about that. That's just one example. All right, let's go to another one. if you have y to the fourth plus 3y minus 4x cubed equals 5x plus 1, find the derivative with respect to x. Okay? All right. First thing I'm going to do is I'm going to put parentheses around y to the fourth. I'm not going to put them around the 3y because that's a single y. Not a big deal. I'm going to leave it be. Okay? I know that's pretty easy. And there aren't any other y's around. So, find the derivative with respect to x. That means you're solving for dy dx is what the directions mean. dy dx is another way of saying y prime. Okay? So you're looking for y prime by itself. Okay? So let's get started. So the first thing you do is you take and you put parentheses around y to the fourth. You're going to apply the chain rule to the first term because the second term, the 3y, you can go ahead and you can take the derivative of that pretty easy. The derivative of 3y is just going to be 3y prime. There's nothing special about it. So, the chain rule, I drop the 4 down, subtract 1, then I multiply by the derivative of the inside. So it gives me 4y cubed y prime. And then you have the plus the 3y prime, and then the minus 12x squared equals 5. All right, so that's the first step in taking the derivative. The second step would be to get y prime by itself. So let's go through this again. Since I'm not here, I'm not sure how this is going. I can't see you. First step, put parentheses around all the y's that are not isolated or by themselves. The 3y is an example of not needing parentheses. 2, you take the derivative using the chain rule, multiplying it by the derivative of it. 3, you solve for y prime and get it isolated. If it asks for the slope of the tangent line, you would put in x's and y's into that. Okay? So, we've done step number 1. We've done step number 2. Step number 3 now is to get the y primes by themselves. If you have y prime in more than one term, how do you get it isolated? Yep. Thank you. You factor it out. So I'm going to take this to the other side, and I'm going to factor a y prime out. So I've got the 12x squared to the other side, factoring out a y prime, and now I divide, and you got y prime equals 12x squared plus 5 equals, or divided by 4y cubed plus 3. That is the y prime. Okay? Excellent. Now, since this is an implicit equation, you're going to have an implicit derivative. Okay? We talked about that. Implicit derivative from an implicit equation. All right. Let's try another one, shall we? Find the slope of the tangent line to the graph y to the fourth plus 3y minus 4x cubed equals 5x plus 1 at the point 1, negative 2. Does anybody notice anything familiar about this equation? Yep. We just found the derivative. First step was we put the parentheses around the y to the fourth. The second step was we used the chain rule for that derivative. And when we took it, we multiplied it by the derivative of the inside. Then we solved it for y prime equal all the x's and y's. And then finally, the fourth thing, we're going to use the x's and y's to find the slope of the tangent line. So we are at the fourth step on this problem. There's the derivative. I put in 1 for all the x's and negative 2 for all the y's, and that gives me the slope of the tangent line. It's pretty obvious you're not going to be able to punch this down the TI to find the slope of the tangent line. You're going to put it through there and grind it out. All right? So you put in the 1, you put in the -2. If you're going to do it in one calculation on a TI, don't forget your grouping symbols in the numerator and denominator. All right, go ahead and punch that out, and make sure you're punching it out correctly. I'll give you a minute. All right, hopefully you got the answer of -17/29. At least that's what I got. Okay? -17/29. Let's see, 12 plus 5 is 17. Looks good. -8 times 4. -32 plus 3 is 29 with a negative in front. Yeah, looks good. All right, questions so far? Never mind. All right, let's go. Moving on. If 5x squared plus 2x squared y plus y squared equals 8, then find the derivative with respect to x. All right? Again, the directions mean they want to know what is y prime. Okay? They want to know what is y prime equal to. All right, first of all, 5x squared, I can take the derivative of that pretty easy. 2x squared y. Y is not by itself. It has an x squared with it. So that gets parentheses. The y isn't by itself in the y squared, so that gets parentheses. And now we're ready to take the derivative. Okay? I would like parentheses around that. So, on the first one, we're going to use the power rule. Pretty easy to do. Drop the 2 and subtract. On the second term, this is an F, that's a G. We're going to use the product rule for that one. And for the third one, well, we're just going to use the chain rule. Yes, when I do the F prime of G plus F G prime, I will use the chain rule on the Y also. Okay? I'll use the chain rule on the Y also. But you're getting an idea of what your answer is going to look like. You're going to end up with 4 terms in your answer. The first term will be from the 5x squared. The second and the third will be from the product rule. And the fourth will be from the chain rule. Remember, terms are separated by addition and subtraction signs. All right? So let me clean this up. That's an explanation about how we're going to go about the problem. So let's get started with the problem. And again, I would like to see parentheses around the y right here to remind me to do the chain rule. So, power rule right here. Power rule. This is f prime with the 4x. That is g with the y. 2x squared, and here's the derivative of y. There's f. There's g prime. There's 2x squared y prime. And here's the use of the chain rule. Okay? So we got our 4 terms. Now we got to take those 4 terms and solve them for y. Okay? This gets kind of confusing, but if you stick with it, it's fine. Also, you got student solutions to help you through this on the weekend if you need it. And I'll be back next week to answer questions. All right, 10x, 4x, y, 2x squared y, y prime, plus 2y, y prime. Now you got to get y prime by itself. First rule, got the parentheses. Second rule, did the chain rule. Third rule, got to get y prime by itself with the x's and y's. Or third step, sorry. All right. So anything without a y prime is going to the right. Anything with a y prime is going to the left. That's just the way the problem is. It stays positive. Hopefully you've already finished this and you factored out the y prime that's common to both, and you divided to get your answer, and you can simplify, divide everything by 2. All right, I don't see any glaring mistakes on that one. You got a quotient. If there was, step number 4, you would put x's and y's into this equation to give you the slope of the tangent line, if there were x's and y's. All right. Well, I think that's about it for that one, isn't it? All right, let's move on. I bet next one's step number 4. No, it's not. If y equals x squared sine of y, then find the derivative with respect to x. Again, the derivative with respect to x means for you to find what y prime equals all by itself. That is our third step. Second step is to use the chain rule for any y's that have a parenthesis around them. And this one will. Okay, go ahead and try this one for, I don't know, 30 seconds, just to see if you're getting anywhere. Keep the room quiet, please. There's a lot of you in here. Keep it quiet and give it a shot. 30 seconds. Let's see. Okay, on your mark, get set, go. 30 seconds. Five, 4, 3, 2, 1, time. Okay? So, first step, parentheses. Next one. Second step, taking the derivative. The derivative of the first term is y prime. Then hopefully you saw that you had to use the product rule. The first function is going to be the f function. The second one is going to be the g function. Hopefully you know that there are going to be 3 terms in your answers, separated by addition, subtraction, and equal sign. So you got the y prime. That's good if you got that far. 2x is the derivative of f, and sine of y is g, plus x squared cosine of y times y prime. Again, the chain rule is I take the derivative of the outside, which is sine. The inside stays the same. And then you multiply by the derivative of the inside, which is y prime. All right, third step. Got to get all the y primes together. I'm going to go to the left, for sure. So I'll subtract it over. And then, when you have y primes, common each term, you go ahead and factor them out, and then divide to get your final answer. Really can't simplify, but you can see that, holy cow, with all the x's and y's, that would just be fun to find the slope of the tangent line of. That'd be a blast. All right, so on the next one, let's get started. Oh, this is a present from last year's class. Every time you see this, you're supposed to think of them. And the mining tools represent you digging on your own. You have to learn how to stand on your own 2 feet as a student. So those are mining tools. We came up with that little badge as a sign that this is the part of the lesson where you got to stand on your own 2 feet. Don't be looking off other people's paper. And if I was in the room, you'd actually be getting out a separate sheet of paper. We'd be taking a quiz. This starts now and goes through, I think, till May, actually. So this is from last year's class. It's a way of saying we did it. Let's see if you can do it. And they said actually they doubted it. All right, so let's get started. This lesson introduces what type of differentiation? Yep, that's right. Implicit. If you didn't have enough time to write it down, too bad, you got it wrong. It is implicit. Whenever I play this game, remember, spelling could be wrong, but in this case, it was correct. Implicit functions are functions that have more than one y, and y is not equal, no, actually it could have one y, but it doesn't say y equals. It doesn't have one single isolated y. Y can be anywhere, it can have more than one. How many explicit functions can be determined? Well, I'll give you this one. I say the answer is 2, but some people say the answer is 4. I'm not really concerned about that. This one. Is the following equation, is it defined explicitly? A for true, B for false. That's right. The answer is false. It is not explicitly defined. In fact, given your algebra, you would be hard-pressed to define this for y. Oh, sure, you could do it. 3xy minus 10 equals 0. You can start by using the quadratic. You know, the opposite of b plus or minus the square root. You know, the square root of b squared. You could do that if you wanted to. That'd be hard to graph. Again, plus or minus means there's going to be 2 equations anyway. And this one I want you to try on your own. The next one. Find the slope of the tangent line to the equation 2xy plus 4 equals 8 at the point 1, 2. Again, the first thing you always check, is this on the graph? This one is on the graph. I think. 2 is 4 plus 4 is 8. Yeah, on the graph. It makes it easier. Try this one from start to finish. Step number 1, step number 2, step number 3, and then finally step number 4, x's and y's. All right, so try this one for, like I said, just about 30 seconds, 45 seconds. I'll start the timer as soon as I get to my clock. And there we go. 30 seconds, go. All right, 20 more seconds. I'm going to cut it short. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right. Hopefully you got the answer as -2. That's what I got. How to use the product rule? Product rule would have been 2 times y plus 2xy prime equals 0. Solve for y prime. You end up with -y over x after you simplify it. Put in the -2 over the 1, you end up with -2. All right, since I'm not there, go ahead and start on this homework that we do next week. Again, student solutions are online. Page 151, 1 through 17 odd. And if I don't see you, have a great weekend. And if you have questions, like I said, go to the student solutions. All right, I'm out of here. Thanks. Have a nice weekend.